Good day. Today we are looking to understand parallel and perpendicular lines in the context of the Cartesian plane. So our objectives today are to 1. Investigate and recall the relationship that exists between the gradients of parallel and perpendicular lines, as well as to solve basic problems using the relationship between these gradients. So let's start by looking at parallel lines. How can we figure out the relationship between the gradients between these? Let's remember our formula for gradient. M is equal to rise over run. So we'll be looking visually at the gradient of these lines. Let's look at the gradient of this first line here. If the gradient is rise over run, we need to know how much it goes up compared to how much it goes across. So if we look at these points, we can see that it goes up 1 and it goes across 2. Up 1, across 2. Up 1, across 2. So the rise is 1 and the run is 2, which means then that the gradient is 1/2. Let's look at this other line here that is parallel to the first one. It goes up 1 and across 2, up 1 and across 2, all the way up 1 and across 2. So its gradient is also 1/2. So that is the relationship we have discovered between parallel lines. And that is that they have the same gradient. If we call the gradient of the first line M1 and the gradient of the second line M2, then mathematically it can be stated as M1 is equal to M2. Let's now look at perpendicular lines. Again, we use the formula M equals rise over run. So let's look at the gradient of this first line here. How much does it go up? 1, 2, 3 units. How much does it go across? 1, 2, 3, 4 units. And between any two successive points, we find that that is the same relationship. Up 3 and across 4. Up 3 and across 4. So the gradient of this line that is in red is 3 over 4, 3/4, because the rise is 3 and the run is 4. Let's look at this second line, the one sloping downwards. Let's see. It goes actually down 4 and across 3. Down 4 and across 3. Down 4 and across 3. Since it is going down, then the rise is negative. So since it goes down 4, the rise is -4, and across 3, the run is 3, so the gradient is -4/3. What relationships exist between these two numbers? They're not the same, but they are very similar. Well, this one here has a gradient of 3/4, and this one, the gradient is -4/3. If you look at it, basically, this second gradient here is this one flipped upside down, and the sign has changed from positive to negative. So in other words, we can say that this second gradient is the negative reciprocal of this first gradient. So that's our relationship. Perpendicular lines have gradients that are the negative reciprocals of each other. Stated mathematically, M1 times M2 is equal to -1, or M1 is equal to -1 over M2. So let's look at an example using what we have just learned. What is the equation of the line that is parallel to the line y equal 5x minus 7 and passes through the point 0, 4? So let's see. If it is the line y equal 5x minus 7, from that we can identify the gradient as being 5. So the gradient of our first line is 5. Now if there are parallel lines, then the gradient of the second line will also be 5, because parallel lines have that property. They have the same gradient. The general equation of a line is y equal mx plus c. We already know that the gradient of our second line is 5. All we need to do now is to find the value of the y-intercept c. How do we find that? Well, we use the point 0, 4. If it is the point 0, 4, we should notice that the x value is 0. And as we should know from before, let's recall that when the x value is 0, then that is the y-intercept. So if it is the point 0, 4, then we already know that the c value is 4. So our answer is simply y equal 5x plus 4. Let's look at a second example. What is the equation of the line that is perpendicular to the line y equal -7x over 10 plus 2? and it passes through the origin. Well, let's see. If it is y equal negative 7x over 10 plus 2, then identifying the gradient would be negative 7 over 10. So if that is the gradient of our first line, and our second line is perpendicular to that, to find the gradient of the second line, all we need to do is to flip the gradient of this first line, in other words, find the reciprocal, and change its sign. So if I flip it, it will become 10 over 7, and if I change the sign, it goes from negative to positive. So the gradient of the second line that we're looking for is 10 over 7. Now, if it passes through the origin, then the origin has coordinates 0, 0, which then means that the y-intercept value c is equal to 0. So our answer for our second line is simply y equals to 10x over 7. So let's summarize what we have learned so far. 1, parallel lines have the same gradient. And 2, perpendicular lines have gradients that are the negative reciprocals of each other, meaning m1 times m2 is equal to negative 1, or m1 is equal to negative 1 over m2. So practice on these problems, pause the video here, and when you're ready to continue, the answers will be shown in 3, 2, 1. If you liked this video, please give it a thumbs up and subscribe, and you can also watch these other videos that you see there. Thank you. Have a nice day.